If you're watching this, it's because you made a little error on the last problem of your mini summative. So this is just going to go over that question and give you a couple of practice ones to do before reassessing. So I'm going to go through each of these problems. It's good to know how to do each one because when you do your reassessment, it'll be kind of the same. You'll have a choice of two different problems, and it's just good if you know how to do both of them. So I'm going to start with question number one, or option number one, the circular track problem. There's lots of different ways that you could solve this problem. I'm going to go ahead and use, I'll use a double number line on this one. Maybe I'll show you with the table too, because both are pretty straightforward. And you could use different methods for this. I just like to use some sort of a visual to make sure I'm getting the things that I want. Now, the important thing here is we're asking about speed. And the units that I'm using are miles and hours. And so the speed is going to be miles per hour. Okay, that's important to know. And if you want, put miles per 1 hour. That's how we would be measuring speed. It's always per 1 unit of time. Okay, so if I looked at this, and let's just put my distance on the top, my time on the bottom, start at 0. And we know that 1/4 of a mile, so 1/4 of a mile, takes 1/20th of an hour. Now, what I want is to get up to 1 hour. So you think, all right, so if I'm at 1/20th, how do I get up to 1 hour? Well, 1/20th times, if I take 20 of those, that is going to get me to 1 hour. So in order to keep my ratio the same, I got to do the same thing on the top. Multiply that by 20. And if I do, I'll just do it off here to the side. 1/4 times 20, remember that's like 20 over 1, which is 20 over 4, which is 5. So if the Elena is running at this rate, that means that she is going at 5 miles per hour. That would be her speed. So the double number line is one way to do that. Of course, we could have also done a table with distance and time and, set it up at 1/4 of a kilometer for 1/20th of an hour and, multiplied by 20 and just showed it this way as well. And that would have been fine too. Or you could have used some other method. All right, the important thing is to show your thinking. So what I want you to do now is kind of apply this same logic and reasoning. And if you need to, you can review this, go back and review this to answer the following question. All right, so hopefully you're able to go through and do that. I'm just going to show you the solution right here. I'll use a table this time. So we've got distance and time. And so the distance, all right, sorry there, the phone rang and got interrupted, but I'll just keep on going. So I'll use the table this time. The boat traveled 2/3 of a kilometer in 1/5 of an hour. So the question is, because I'm doing speed, now this is going to be in kilometers per hour. That's the units that I want to use. So how many kilometers am I going to travel? Well, to go 1 hour from 1/5 to 1, I've got to multiply by 5. So I do the same thing here, times 5. And that is going to give me 10/3. Now, you could say the answer is 10/3 kilometers per hour. I would probably write that as 3 1/3 kilometers per hour, just because that probably makes a little bit more sense in the context of this problem. But really, either one of these, 10/3 or 3 1/3 kilometers per hour, would be acceptable. And don't forget to include that unit when you're writing your answer. All right, option number 2, the baking problem. So on this one, a rectangular prism is just like a box. Okay, hopefully that didn't confuse anyone there. And do a little sketch right here. A diagram is always a good way. It says the area of the rectangular piece of foil is 11 1/4 inches. So that covers the bottom. So we know that right there is 11 1/4 inches. Its length is 4 1/2. So let's say, I'll say 4 1/2 is this length right here. I mean, you could have also made this the length on that side, but I'm just going to make that the width. And so that's what we're trying to find, the width. Okay, well, in order to find the area of a rectangle, you do length times width. So if you know one of those, I know the area is 11 1/4. I know the length is 4 1/2, and I'm trying to find the width. That's my unknown. Well, to find that unknown in a multiplication problem, to find the width, one way to do that is to take the area and divide it by the length. So that's what I'm going to do on this one. To find that width, or that question mark, I'm going to take 11 1/4, and I'm going to divide it by 4 1/2. Okay, so let me just move this over so I got a little bit more room to work with. So this just goes into our fraction division. I would probably turn these to improper fractions. So this would be 45/4. And if you aren't sure how I just did that, make sure you come chat with me, because that's just a skill that's going to help you on all these problems. And that's going to be 9/2. And there's different ways you could approach this. One way is to use the reciprocal, 45/4 times 2/9. And I could just multiply these together, but you make your life a lot easier if you do some simplifying first. For example, 45/9. I can simplify that fraction. If I divide each of those by 9, that's going to become 1, and that's going to become 5. Similarly, 2/4 can be simplified to 1/2. Now when I multiply, the numerator, 5 times 1, is just going to be 5. The denominator, 2 times 1, is just going to be 2. So that is my answer, okay? The width is going to equal, you could write 5/2 inches, or probably a better way to write it, though, in this context, is 2.5 inches. So that would be my answer for question option 2. So I'd like you to take a second, answer this question. All right, for this one, we'll see how you did. The area is, remember, area is length times width. It's always a good idea to start by writing the formula you're using. So to find the length, I'm going to take the total area and divide it by the width. Well, in this problem, that's 3.5 divided by 2 1/3. And turn these to improper fractions, 7/2 and 7/3. I'll use the reciprocal. And let me remind us why I do that reciprocal. What I'm doing here is 7/2 divided by 7/3. And I want to change this. I just rewrote this problem right here. And so what I want to do is I want to make this as something over 1. So to make that denominator 1, I'm going to multiply it by 3/7. And remember, if you take a fraction and you multiply it by the reciprocal, that makes it 1, which is exactly what I want. But in order to keep this fraction equivalent, I got to multiply the top by 3/7. So 7/2, and let me simplify first. 7/7 simplifies to 1/1. So when I multiply these together, the numerator, 1 times 3 is 3, and the denominator is 2 times 1 is 2. So this is just equal to 3/2, or 1 1/2. So the length in this problem is going to equal 3/2, or 1 1/2 inches. If you got that, awesome. If you still need a little help, make sure you check in with your teacher.